Now we're going to discuss converting between polar and rectangular coordinates. And these formulas below will help you convert between polar and rectangular coordinates. All right, so with that, let's look at these examples. So the first one, 1 comma 1. Let's apply the Pythagorean theorem. So we end up with 1 squared plus 1 squared equals r squared, so r equals root 2. Then tangent of theta equals y over x equals 1 over 1. So theta has to equal pi over 4, giving us the polar coordinate of root 2 comma pi over 4. Next, let's look at 0 comma 2. So let's apply what we've been doing. 0 squared plus 2 squared equals r squared, giving us r equals 2. And then here is where we're going to run into some tricky problem. So tangent of theta equals y over x, and that gives us 2 over 0. But this is undefined. So we have to try doing this a different way. Let's draw a Cartesian coordinate plane here. So this is x, this is y, and this is 1, here's 2. So this is the point 0 comma 2. So clearly the radius, this distance 1, 2 is 2. But what is the angle? Well, that we can quickly figure out. Using what we already know, we can see that theta is pi over 2. So this point is root 2 comma pi over 2. Excuse me. 2 comma pi over 2. Finally, let's look at our last point. We have root 3 comma 1. So root 3 squared plus 1 squared equals r squared. So r equals 2. Next we have tangent of theta equals y over x. So equals 1 over root 3. This is where we have to really remember our trigonometry. So if you recall, all our really nice angles are usually 1/2 and root 3 over 2. And so I'm going to use this fact and some algebra skills to rewrite this as 1/2 over root 3 over 2. So this is where you have to ask yourself, where on the unit circle is the sine value equal to 1/2 and the cosine value equal to root 3 over 2? We're right here at pi over 6. This triangle, right triangle here, and I'm just noticing your cutoff, so let me scooch it over. So this right triangle here has an x value of root 3 over 2. And when I say x value, I mean the coordinate. So this point is root 3 over 2 comma 1/2. And the 1/2 is this vertical value here. So that's our 1/2. So this here tells me that theta equals pi over 6, and this angle in polar coordinates is 2 comma pi over 6. So for part B, let's convert the following into rectangular coordinates. Let's start with 2 and then pi over 3. So I know that r equals 2 and theta equals pi over 3. So I can simply write x equals 2 times cosine pi over 3, y equals 2 times sine of pi over 3. Cosine of pi over 3 is 1/2 times 2 gives us just 1. And then for y, sine of pi over 3 is root 3 over 2, so we end up with just root 3. So this is the point 1 comma root 3. Let's look at the next one. So we're given 6 comma negative 5 pi over 6. So r equals 6. And theta equals negative 5 pi over 6. So we can write x equals 6 cosine of negative 5 pi over 6. and y equals 6 times sine of negative 5 pi over 6. So this becomes negative root 3 over 2 times 6, which is just negative 3 root 3. Let's do the same thing for sine of 5 pi over 6 times 6. So we will end up with 1/2 times 6. So this is 1/2 times 6 to get 6 over 2 or 3. So this point here is negative 3 root 3 comma 3. And I'm going to squeeze this last one in at the bottom here. So our last point is 1 comma 3 pi over 2. R equals 1. Theta equals 3 pi over 2. So x equals 1 times cosine of 3 pi over 2. Y equals 1 times sine of 3 pi over 2. So 3 pi over 2 has a cosine value of 0, so x equals 0. And 3 pi over 2 has a sine value of negative 1, so we have 1 times negative 1, which is negative 1. So this is the point 0 comma negative 1.